All right, let's talk about a huge hidden cost in production AI. Imagine you're running a customer support chatbot. It's handling thousands of questions a day, and every single one triggers an expensive API call. Now, even when users ask the exact same thing you answered just 5 minutes ago, you're still paying to generate that same response all over again. It's one of the biggest and most unnecessary money drains out there.
And just how big are we talking? Well, for a chatbot that's handling about 10,000 requests a day, that repetitive cost can easily stack up to $180,000 a year. That is a massive expense for work your system has literally already done. But the good news is, you can get almost all of that back.
So, how do you stop this cycle of just throwing money away on redundant work? Well, there's a technique that production AI teams basically consider their secret weapon. It's called prompt caching, and it is the definitive solution to this very, very expensive problem.
Okay, so let's really dive into what this is. At its core, caching is a beautifully simple idea, but one that has a massive impact on your system's performance and, your bottom line. Think of it like a really smart librarian. The first time somebody asks a super specific question, that librarian goes deep into the library stacks to find the answer. But if someone else asks the exact same question 5 minutes later, does the librarian run all the way back to the shelves? No way. They just remember the answer and give it to you instantly. That's exactly what prompt caching does for your AI.
And the difference here is it's night and day. Just look at these numbers. A live API call might cost you, say, 5 cents. A cache hit, it costs you nothing. 0. And the speed? You go from waiting 1 to maybe 5 seconds for a response, all the way down to just milliseconds. We are talking 100 to 1,000 times faster. This isn't some small optimization, it is a total game changer for user experience.
So how does this magic actually work in practice? Well, it's not just one single technique. There are a few key strategies, and they range from the incredibly simple to the brilliantly advanced.
Okay, so the most basic approach is called exact match. It basically creates a unique digital fingerprint for the text to see if the prompt is identical to one it's seen before. This is perfect for stuff like FAQs. But what if a user asks, "Tell me about your return policy," instead of "What is your return policy?" Well, that's where semantic caching comes in and really shines. It uses AI embeddings to understand that both of those questions mean the same thing. And this is where the magic happens. It can boost your cache hit rate from around 40% all the way up to 80%.
And there are other powerful methods too. You've got context caching, which is a game changer for chatbots because it remembers the conversation history. That means you don't have to resend the entire chat log with every single message, cutting your token usage by up to 40%. And for anyone using OpenAI, it's gotten ridiculously easy. Their new cache API lets you turn it on with a single parameter, cache equals true, and all your cache hits are completely free.
All right, so you can see the power here. Let's get practical. We're going to move to the how and look at a clear, actionable playbook you can use to get this running in your own systems.
It really boils down to this 6-step roadmap. First, you find where caching is going to have the biggest impact. Then, you pick the right strategy for that job. After that, you'll design a smart structure for your cache keys, you'll implement the code, set rules for how long to keep the data, and finally, you monitor everything to see just how well it's working.
Now, I really want to pause on step 3, because this is where so many people get it wrong. Your cache key is everything. It's the unique ID for a request. And if you mess this up, you could end up serving completely wrong answers. I mean, imagine a customer asking for their account balance and getting someone else's. That's the kind of disaster a bad cache key can cause.
So the crucial point here is that a perfect cache key has to include everything. And I mean everything that could possibly change the AI's response. That means the prompt itself, the specific model you're using, any parameters like temperature, and even a version number for your prompt. If any one of these things changes, it has to be a cache miss. That's how you guarantee you always serve the right response. So, let's say you follow that playbook. You get it all right. What's the payoff? And, just as important, what are the common traps you really need to look out for?
The payoff is immediate, and it is huge. This chart shows the monthly cost for our example chatbot. Without caching, it's 15 grand a month. But with a totally achievable 60% cache hit rate, that cost plummets down to $6,000. That is a $9,000 saving every single month.
So what's the return on investment for the few hours you might spend setting this up? Well, it can be absolutely astronomical. We're talking an ROI on your implementation time of over 13,000 to 1. This is especially true if your business has lots of repetitive queries. Think e-commerce sites, support platforms, internal knowledge bases.
It is one of the highest leverage things you can possibly do. Now for the pitfalls. This quote right here highlights a super simple but really costly mistake. Normalizing just means cleaning up the prompt. Making it all lowercase, getting rid of extra spaces. If you don't do that, what is your return policy with a lowercase w will be a cache miss, even if you've already answered the one with a capital W. It's a simple fix that can instantly boost your hit rate. And that leads us to the biggest mistakes people make. Bad cache keys, like we talked about, are the #1 culprit. Next is setting the wrong TTL, or time to live. You don't want to cache breaking news for a week, right? You have to match the cache's lifespan to your data. Not normalizing prompts is another big one. And finally, flying blind. If you don't monitor your hit rate, you have no idea if your caching is even working.
So let's just quickly recap the most crucial takeaways here. Number 1, caching makes repeated requests totally free. 2, the responses are practically instant. We're talking 100 to 1,000 times faster. 3, you can realistically expect a 60 to 80% cache rate. 4, the golden rule, your cache key has to include all model parameters. And finally, you have to monitor your hit rate. It's how you prove this whole thing is worth it.
And that brings us to the final question, the one I want to leave you with. Think about the AI system you're building or working on right now. Where are the repeated questions? Where are the template-based generations? What's the first, biggest, juiciest caching opportunity you can go after today?